For decades, Windows has dominated the desktop world. If you walked into almost any office, technology lab, or enterprise environment, the operating system running on those machines was almost always Windows. Microsoft built an ecosystem that seemed nearly impossible to challenge. But something fascinating has been quietly happening behind the scenes in the tech industry. Some of the biggest mobile technology companies in the world are slowly shifting their internal desktop environments away from Windows and toward Linux-based systems. This change is not loud or dramatic, but it is significant, and it reveals deeper trends about how modern technology companies actually build products. To understand why this shift is happening, we first need to understand how mobile giants operate today. Companies that build smartphones, mobile chips, and mobile operating systems rely heavily on software development environments that are extremely complex. Engineers work with massive code bases, automated build systems, virtualization tools, containerized development environments, and custom debugging platforms. These workflows are very different from the traditional office productivity tasks that Windows historically focused on. While Windows remains excellent for enterprise productivity tools, it often struggles to provide the flexibility and deep customization that large engineering teams require. Linux, on the other hand, was designed from the beginning to be flexible, modular, and developer-centric. It powers most of the servers on the internet, almost all cloud infrastructure, and of course the Android operating system that dominates the global smartphone market. For companies whose entire business revolves around mobile platforms and cloud services, Linux is not just another operating system. It is the environment their engineers already live in every day. One of the biggest factors driving this transition is development workflow efficiency. Mobile operating systems like Android are fundamentally built on top of Linux. When developers compile Android builds, test kernel modules, or debug low-level system components, they are working directly with Linux-based toolchains. Running these tools on Windows often requires compatibility layers, virtual machines, or additional abstraction tools that slow down the process. On a Linux desktop, the environment is native. Build systems run faster, command-line tools behave exactly as expected, and developers can customize their workflow without restrictions. Another major factor is containerization and cloud development. Modern mobile development relies heavily on container technologies like Docker and Kubernetes. These technologies were originally designed around Linux kernel features such as groups and namespace. While Windows now supports many of these tools, the experience is still often smoother and more predictable on Linux. When engineers are building distributed services that interact with mobile devices, they benefit from working in the same environment that powers their production servers. Security also plays a crucial role in the shift toward Linux desktops. Mobile companies handle extremely sensitive intellectual property, including unreleased device designs, chip architectures, operating system features, and proprietary algorithms. Linux offers a level of transparency and control that proprietary operating systems simply cannot match. Because the source code is open, companies can audit every component of the system and modify it to meet their internal security requirements. They can remove unnecessary services, lock down permissions, and deploy hardened configurations across thousands of machines. In addition to security, stability is another reason mobile companies prefer Linux desktops for engineering teams. Linux distributions are known for their ability to run for long periods without requiring reboots. For developers who frequently run heavy workloads like compiling entire operating systems, stability matters a lot. A workstation that crashes or forces frequent updates can interrupt hours of build processes. Linux environments allow engineers to control updates more carefully and maintain consistent development environments over time. Cost is another practical factor influencing this shift. Large technology companies operate tens of thousands of employee workstations. Licensing costs for proprietary operating systems can add up quickly at that scale. Linux distributions are typically free and open source, which allows companies to deploy them without paying per-machine licensing fees. But the real cost advantage goes beyond licensing. Because Linux is highly customizable, companies can create their own internal distributions optimized specifically for their workflows. This reduces overhead, improves performance, and eliminates unnecessary software. Another major reason mobile giants are adopting Linux desktops is the alignment with their internal infrastructure. Most large tech companies already run Linux servers across their data centers and cloud platforms. When developers use Linux on their desktops, the gap between local development and production environments becomes much smaller. This concept is often referred to as environment parity. If developers write code on Linux machines and deploy it to Linux servers, they are far less likely to encounter unexpected compatibility issues. There is also a cultural aspect to this transition. Many software engineers simply prefer Linux. The operating system provides powerful command line tools, scripting capabilities, and customization options that allow developers to tailor their environment to their exact needs. Developers can choose different desktop environments, window managers, shells, and programming tools. This flexibility creates a workflow that feels efficient and personal rather than constrained by a single predefined interface. Another interesting factor is the rise of open-source collaboration. Mobile technology companies contribute heavily to open-source projects, including the Linux kernel, Android, graphics drivers, networking tools, and development frameworks. When engineers work on Linux desktops, they are operating in the same ecosystem where these open-source projects are developed. This makes it easier to contribute patches, test kernel features, and collaborate with the broader open-source community. Hardware support has also improved dramatically for Linux desktops in recent years. In the past, one of the biggest challenges for Linux adoption was inconsistent hardware compatibility. But today, most major hardware vendors provide excellent Linux support, especially for the types of hardware used by software developers. Graphics drivers, Wi-Fi chipsets, power management systems, and high-resolution displays are now widely supported across modern Linux distributions. Another technological shift pushing mobile companies toward Linux desktops is the rise of remote development environments. Many engineering teams now use cloud-based development platforms where the actual code compilation happens on powerful remote servers. In this model, the local desktop becomes more of a lightweight interface for accessing remote resources. Linux desktops integrate extremely well with SSH-based workflows, terminal multiplexers, and remote container systems, making them ideal for this style of development. Windows has attempted to address some of these gaps with technologies like Windows Subsystem for Linux. WSL allows developers to run a Linux environment inside Windows without needing a full virtual machine. While this has improved the developer experience significantly, it still adds an additional layer between the developer and the native Linux environment. For many engineering teams, it simply makes more sense to run Linux directly instead of running Linux inside another operating system. Another subtle but important reason mobile companies prefer Linux desktops is automation. Large engineering organizations rely heavily on automation to manage thousands of development machines. Linux systems can be configured and deployed using powerful automation tools such as Ansible, Puppet, and Chef. These tools allow IT teams to create standardized workstation images, push updates automatically, and ensure that every developer machine follows the same configuration policies. Linux also excels in performance when running development workloads. Compiling large projects like Android or mobile chip firmware can push workstations to their limits. Linux's efficient process scheduling and resource management often result in faster compile times compared to other operating systems. Even small improvements in build speed can save enormous amounts of developer time when multiplied across thousands of engineers. Another advantage is the modular design of Linux distributions. Companies can create customized versions of Linux that include exactly the tools their engineers need and nothing more. This reduces system overhead and simplifies maintenance. Some organizations even maintain internal Linux distributions specifically tailored for their development workflows, including pre-configured toolchains, debugging utilities, and security policies. There is also an increasing push within the tech industry to reduce reliance on single vendors. Vendor lock-in can become a serious strategic risk if a company's entire development ecosystem depends on proprietary software controlled by another corporation. By adopting Linux desktops, mobile companies gain greater independence and control over their technology stack. They are no longer dependent on the decisions, licensing models, or product roadmaps of a single operating system vendor. Mobile device development itself also benefits from Linux environments. Engineers working on smartphone kernels, drivers, and firmware need direct access to low-level debugging tools. Linux provides a rich set of kernel development utilities that integrate naturally with embedded systems. This makes it easier to test device drivers, analyze system logs, and debug performance issues directly from the desktop environment. Another important factor is the growth of cross-platform development tools. In the past, some essential applications were available only on Windows. But today, many of the most popular development tools run equally well on Linux. Integrated development environments, version control systems, container platforms, and programming languages are all designed to work seamlessly across Linux systems. Artificial intelligence and machine learning workloads are also influencing the desktop operating system choices of mobile companies. Training models, testing AI features, and running GPU-accelerated workloads often works better on Linux because many machine learning frameworks are optimized for Linux environments. GPU drivers and compute libraries are often released first for Linux platforms, giving developers earlier access to performance improvements. The rise of Linux-based desktop environments has also made the user experience significantly more polished. Modern Linux desktops offer smooth animations, advanced display scaling, multi-monitor support, and powerful productivity features. For many users, the experience is now just as refined as traditional commercial operating systems. Interestingly, this shift does not necessarily mean Windows will disappear from enterprise environments. Windows still plays a major role in office productivity, business applications, and enterprise software ecosystems. However, within engineering teams and development departments, Linux desktops are increasingly becoming the preferred choice. The transition is also gradual rather than immediate. Companies rarely switch thousands of machines overnight. Instead, they often start by allowing engineers to choose their preferred operating system. Over time, as more developers adopt Linux and internal tools become optimized for it, the Linux user base grows naturally. Another reason this change is gaining momentum is the influence of younger developers entering the workforce. Many new engineers are already familiar with Linux because they used it during their studies or personal projects. Universities and coding bootcamps often teach programming using Linux environments, which means new graduates arrive with Linux skills already developed. Open hardware initiatives are also contributing to this trend. As more companies design custom hardware platforms, Linux provides the flexibility needed to support new architectures and experimental hardware designs. Developers can modify drivers, kernel components, and system libraries to support new devices without waiting for proprietary vendors to release updates. Even user interface customization plays a role in developer productivity. Linux desktops allow engineers to configure tiling window managers, keyboard-driven navigation systems, and highly efficient workflows that reduce the need for constant mouse interaction. Over time, these optimizations can significantly improve productivity for developers who spend long hours writing and reviewing code. Another key reason mobile giants are shifting toward Linux desktops is that the ecosystem continues to evolve rapidly. Improvements in package management, desktop performance, graphics support, and hardware compatibility have made Linux easier to deploy at scale. What was once considered a niche operating system for enthusiasts has matured into a robust enterprise platform. When you combine all these factors together, developer efficiency, security, cost savings, infrastructure alignment, open source collaboration, performance, automation, and hardware flexibility, it becomes clear why mobile technology companies are increasingly adopting Linux desktops. The shift is not driven by ideology or brand loyalty. It is driven by practical engineering needs. In many ways, this transition reflects a broader transformation in the technology industry. The center of computing power has moved from desktop software to cloud infrastructure and mobile platforms. Linux sits at the heart of both of these worlds. It powers the servers that run the internet and the operating systems that run billions of smartphones. For mobile giants building the next generation of devices, services, and platforms, using Linux on the desktop simply makes sense. It aligns their development environment with the systems they are building and deploying. As a result, the quiet migration toward Linux desktops is likely to continue growing in the coming years. While the average consumer may not notice this shift directly, it represents an important signal about the future of computing. The tools used by engineers often shape the technologies that eventually reach the public. If the companies building tomorrow's mobile platforms are increasingly relying on Linux desktops today, it suggests that open, flexible, and developer-centric systems will continue to play a major role in the evolution of the technology landscape.